Hello, everybody, and thank you for joining us today. My name is Jake, and I'm excited to be here today, presenting workflows that are available in Surfer to help you master coordinate systems. Even if you are a brand new Surfer user, we hope by attending this webinar, you will walk away confident in the workflows Surfer offers to manage coordinate systems for your data, map, layers, and exports. And if you are a prospective Surfer user who hasn't opened the program yet, do know that you can download the free trial quickly from our website's download tab and follow along while we go should you desire. In today's presentation, we are going to cover Surfer terminology associated with projections and coordinate systems, how to reproject raw data and map layers to a new coordinate system, how to combine layers that use different coordinate systems, and how to export maps in your desired coordinate system for use in third-party applications. There will be a few stopping points along the way where I will address questions. You can send your questions to the webinar host via the Q&A located on the Zoom toolbar at any time. Type in your question and it will be sent to the webinar host who will either answer it or forward it to me. And please use the Q&A function rather than the chat. This will allow the host to ensure we see all questions in a timely manner. Feel free to send in all your questions, and if we don't have time to answer them during the webinar, we will answer them via email once the webinar is complete. And this webinar is being recorded. Later this week, we'll post the recording along with the data used. We'll send an email with the recording to everyone who registered once it's posted, so you can test these examples out for yourself. So now let's get started by covering some key Surfer terms that are going to be referenced throughout this webinar. As many of you probably already know, every data set, data file, grid file, image, base map, base layer, and map layer in general has a coordinate system. This system is used to locate files within a map and combine them with other map layers such as base, contour, or color relief layers. Every map layer you create in Surfer has an associated coordinate system. Even if you import a completely unreferenced file, Surfer will utilize a local coordinate system. A local system will begin numbering at an arbitrary location and increment numbers equidistant in the X and Y directions from this location based on the data in the file. This demo grid base map I have here is an example of this. It's referencing the X and Y data associated with the TIFF file that it's created from. But if I look at its coordinate system here in the property manager, it is currently an unreferenced local system. This demo grid specifically does use arbitrary X and Y numbers, but if the data it referenced was collected in a real-world coordinate system, such as a projected UTM system, the data would display as such, and I could tell Surfer what this unreferenced coordinate system was by clicking Set. By clicking Set, the assigned coordinate system window will open, and Surfer ships with hundreds of predefined common coordinate systems, both geographic and projected. A geographic coordinate system uses latitude and longitude to define the location of points on the surface of a sphere or spheroid. Geographical coordinate systems are commonly referred to as unprojected latitude and longitude systems. Then on the other hand, we have projected coordinate systems. A projected system is used to locate X, Y, and Z positions of a point, line, or area feature in 2 or 3 dimensions. It's important to note that if you're going to be converting data between geographic and projected coordinates, you're most likely going to encounter warping of your final output due to the fact that one references 2 and 3 dimensions and the other is based on a sphere. Now I'm going to go ahead and cover some Surfer-specific terms that will be used today. First is the source coordinate system. The source coordinate system refers to the coordinate system that is associated with a specific map layer. For example, this contours conifer layer. This map layer source system is North America NAD 27, UTM Zone 13 North. And that is the system that the original data used to create the map was set in. Surfer also utilizes a target coordinate system. You can find the target system by selecting the map object in the contents window. And this is the coordinate system associated with an entire map object. Individual map layers can use different source coordinate systems, but anything that you create or add to this map frame will be displayed in that target coordinate system. And it's what you will want your final output data to be displayed in and eventually exported to. The target coordinate system for this map is also North America NAD 27, UTM Zone 13 North. Finally, I'll touch on external reference files. If you've ever been sent data or downloaded data that has an external file type, such as a RSF, PRJ, or Esri world file associated with it, that file contains your coordinate system reference information. The files look like this. Here's a PRJ, and then here is the Golden Software specific GSR2. And mapping applications will use those files to load data in the correct location when you open it up in the application. And I'll show you guys how to create these when we get to the exporting portion of our webinar. And now that we've been introduced to some terms that we can use throughout this webinar, let's start using Surfer to assign and convert some coordinate data. In our first example, we're going to cover how to convert the coordinate system of raw data before you've done any gridding or mapping. This functionality is helpful if you have a client or a technician who collected data in a coordinate system that you already know you don't want to use in the final report. You may not want to use it because it's too region specific or it's just not the preferred way to present your figures. And to convert raw data before it's been mapped, we can open it in the worksheet window. Surfer's worksheet window can open nearly all standard tab delimited file types that data is stored in. To open our data in a Surfer worksheet, we would click File, Open in Worksheet, and then choose your database, which for us is this wellmeasurements.csv. Now that I've opened this data set, we can see that our X and Y location data was provided in a latitude and longitude format. And I already know that the client that we're going to create these reports for would really prefer the final product to be in UTMs. So to avoid having to convert all the map layers I create from this data set moving forward, I can go ahead and use a conversion function now to add 2 new columns to the sheet that will house the corresponding UTM measurements generated from these latitude and longitude columns. Up here in the ribbon, we can see we have a coordinate system tab for the worksheet window. From this tab, you can assign a coordinate system to the sheet, project new coordinates, or if you were given data in a DMS format, you could convert it to decimal degrees. And we're going to be using the new projected coordinates functionality. So I'll click that, which will open up this window here. And when you're setting the options for new projected coordinates, you want to make sure that you are really 100% accurate to keep the integrity of your data. Our support team has definitely worked with end users who will say their map is not displaying data correctly, and it can trace all the way back to setting these columns incorrectly when converting the coordinates at the start of their project. So as I mentioned earlier, the source columns is what our data is now. It's what it was collected in, and the target column is what we want to convert and display to. So let's go ahead and set our source columns. When working with latitude and longitude, the X variable is always longitude. So I will go ahead and set column C longitude to be my X. And the Y variable is always latitude, so I will leave that as column B latitude. Next, we need to set our source coordinate system. And if we click these 3 dots, we'll open the assigned coordinate system window. And I know that this is unprojected latitude and longitude, which would be housed under the geographic coordinate systems. This list is in an alphabetical order, so I could scroll down to the bottom and select World Geodetic System 1984. Once our source information is set, I could set my target columns. The target columns represent what columns our new projected coordinates will fill. And I'm happy to leave those as columns G and H for the time being. And then we would also set our target coordinate system. and that's the system we want to project our source coordinates to. I want to project to UTMs, so I'm going to click the three dots, expand projected systems, expand UTMs, WGS84, and I know that this UTM zone is zone 11 north, so I'll go ahead and select that now. Once our source and target coordinate systems have been set correctly, I can click OK, and Surfer will basically instantly perform this conversion. To make my life easier, when I go to grid this file later, I'm going to go ahead and add a header to these columns. I'll call them UTMX and UTMY. Then I could go ahead and save this as a new data set by clicking File, Save As. And I'll give this a new name so I keep my original data. I'll call it Well Measurements UTM, and I could go ahead and click Save. Okay. And this is a really quick and simple workflow you can use for any project that you're starting from scratch with the data set. You could technically project your source coordinates to as many different systems and as many columns as you need for your project, but we only need these UTM ones. So let's go back to our blank plot window. And then I could now use this data set to make something such as a contour map. To do so, I would click Home, Grid Data, or load in our newly saved data set. And I would set my X to be our UTMX column, my Y to be our UTMY. And then I would choose the Z value I want to create contours from, and I'll use land surface elevation. I could click skip to end, and I said I want to add this as a contour map, which is what we're already set to. So I can go ahead and click finish. And now we have a contour map referencing the UTM coordinate system, even though our data was collected in latitude and longitude. While we're still focusing on projecting raw data before we started mapping, I also want to show off Surfer's grid project feature. From this top ribbon, if I click grids, here in the edit section is a project grid feature. And grid project will take an input grid that you already have on hand, such as that contours, those UTM contours we just made. And you can regrid that data to a new projected coordinate system. It works much the same way as the worksheet feature I just demonstrated. I would set my input grid, set my source coordinate system, set my target coordinate system, and then Surfer would just regrid our data in that new system. You might utilize this feature if you already have a grid file on hand, but it does also work with .dem and .asc files. And that's going to cover converting and reprojecting our data before we start mapping. So now I'm going to take a moment to pause and answer any questions that have come in. All right, one question I'm seeing is, does projecting a grid change my Z value? No, grid project will just affect the X and Y coordinates of a grid. But if you did want to apply a transformation to your Z value, you can do that during the gridding process, or even from the worksheet window. There's some transform and math features you can use on a certain column that you know you're going to be gridding. All right, another question I'm seeing is, why use .csv and not XLS? There's no specific reason for it. You can use an XLS if you wanted. I just happened to save this data as a CSV. The worksheet can open really nearly any standard just data worksheet that you will utilize or be given data in. Okay. And we do have a couple more questions. Let's see. if the project includes two UTM zones, what's going to happen when we convert from latitude and longitude? Surfer can only choose one of the UTM zones for your conversion. So you're going to want to just choose the zone that encompasses most of the data. I mean, if it's a true 50-50 split, then that is what it is. But I would choose the UTM zone that encompasses most of your data, perform the conversion. Anytime you're projecting in between UTMs to lat and long, you're going to have some warp anyhow. You could also, if you wanted, split the data and then try and remosaic it later. It's really just trial and error on whatever you think is going to end up looking best as the final product. And we do have a couple other questions, but we're going to move on so that we can keep this going. If we don't answer them now, we'll answer them via email, and Drew will also type some answers to you guys. All right, for our next example, we're going to move to the section of this webinar where we assign and convert coordinate systems to existing map layers. We know that it may well be a miracle if you are able to collect all the data and map layers you need for a figure within the same coordinate system. With Surfer, there's only a few extra steps you need to take to overlay the mismatched data layers and create that final figure that you envisioned from the start. In this example, we have a great aerial image here in unprojected latitude and longitude, World Geodetic System 1984. And we also have a SHP shapefile that I've added as a base map demonstrating the roads in this area as polylines. As you can see, when I select this base layer here in the contents window, our source coordinate system is unreferenced, but when I look at the axes, I can tell that this is some sort of projected UTM system. Now, even though these are maps of the exact same area, because they're in two different systems, if we would try to overlay them without some editing, we're going to end up with a crazy warped figure. I'll demonstrate what that looks like now. If I drag this base layer into the aerial image map object, I click yes, we end up with this crazy warped figure and we get a warning message. Essentially what this warning message is telling us that because the target coordinate system for that aerial image was World Geodetic System 1984, when I dragged the unreferenced shapefile into the map frame, it tried to read the UTM coordinates as latitude and longitude coordinates, which caused the massive scaling issue. I'm going to go ahead and undo so we split these out again. And all we really need to do to overlay these without the major scaling issue would be to tell Surfer the source coordinate system of the shapefile. To do so, I would select the base vector layer here in the contents window, click set on my source coordinate system, and I could set it to the UTM coordinate system that I know it was collected in, which would be WGS UTM zone 11 north. To find it, you could expand projected systems, UTM, WGS 84, WGS 84 UTM zone 11 north. Click OK. You'll see that didn't change the shape layer at all. What it does is it tells Surfer how to read the data that is in there now. And now because Surfer knows that that source coordinate system is this UTM zone, I can go ahead and do the exact same workflow, and I can drag this base vector layer into my aerial image map object. This time I'm going to click no because I just don't want to expand the current map limits. But now we successfully overlaid the two layers, and that scaling issue is no longer going to occur because Surfer is smart enough to read the source coordinates and display them in the unprojected latitude and longitude that we want it to. Really quickly, I'm going to change the color of these polylines so we can see it against the aerial image. And if I would go in and select my base vector shapefile layer, it is still retaining that source coordinate system of WGS84, UTM zone 11 north. And if I were to expand the layer and look at any of these polylines, then select the coordinates tab, our coordinates are still displaying in the UTM units that it was loaded in as. We essentially are just displaying all of our data in latitude and longitude because that is the target system of the entire map. If you had more map layers that utilize even a third or fourth system, you could use the same workflow of splitting out the map layer, setting the source target system, then adding it to the map frame with your desired target. Now, some of you may want to take this a step further and actually fully convert your shapefile from projected UTM to unprojected latitude and longitude, not just have it display one system, but retain the old. So now I will demonstrate how we can export it to entirely convert the data of a file in case you just wanted to take the shapefile and use it in a third-party application. I'm going to quickly click undo twice so we get back to two separate layers. And recenter. And now when I select our shapefile that's separated out again, we do still have this source coordinate system set of WGS84 UTM zone 11 north. But if I look at our map frame, it does not have a target coordinate system. So now we're going to circle back to the common thread between all of these workflows, which is setting the target coordinate system is going to cause the map to display in the system we desire. And ultimately, we can end up exporting to that system. So I'm going to go ahead and click change down here in the property manager. And I want to change to unprojected latitude and longitude. So I'll expand geographic, scroll down to World Geodetic System 1984. You may have noticed each time I open this assigned coordinate system window, I do have a favorites list. This is a really handy tool if you are using in the same system a majority of the time. You can select any system that's in any of these predefined systems. And here on the right, you can click add to favorites. And now it will populate in your favorites list so you don't have to expand and search for it every single time. You can also remove something from your favorites if you don't actually want it. And moving forward, now that I've shown that favorites list, I'll be working out of the favorites list just so that we don't have to search through all of the coordinate systems each time. And we want to convert to World Geodetic System 1984, so I'll make sure that's selected and click OK. Now we can see we're displaying in latitude and longitude again for the shapefile, but it is still the same deal if I were to expand the base layer, select a polyline and look at the coordinates are still written in the UTM units. So to fully rewrite this, we're going to have to export. And I know I'm going to be exporting this to a shapefile. So what I'm going to do now is turn off all of the axes here in the contents window. Just uncheck the boxes. I'm doing that because when you export to a shapefile, Surfer will pick up those axes as polylines that are meant to be included in it. And then I'm going to go ahead and select the map here in the contents window and click File, Export. There we go. And here in the export window, I'm going to make sure I have this selected objects only checked here. I want to have selected objects only checked so that I only grab that map I selected in the contents window and not the aerial image as well. And then I will choose my save as type as a SHP Esri shapefile. And I will go ahead and name this Diablo Roads lat long so I can differentiate between my original file. Click Save. And now we are going to get to the most important part of this export process, and that is these export options. Specifically, this scaling source is what really matters for rewriting your data. The scaling source, it defines what our target coordinate system is when we export. And right now, as it's set to map, we are referencing the World Geodetic System 1984 target coordinate system. I can confirm that that is the case if I were to look at this XY file rectangle. These seem to be latitude and longitude coordinates, so I'm confident I have the right scaling source selected. A common mistake when exporting would be using the incorrect scaling source, such as paper space. Note how my file rectangle here, the XY coordinates have changed to the actual inches of paper space of this image. If I exported now using paper space as my scaling source, all of my data would be rewritten to inches on the page. And if I opened it up at a later point, the data would basically mean nothing. So always double check you have the scaling source you actually want set. For us, it's map. After our scaling options, we have the spatial references, and these are the external reference files I mentioned at the start. It will save our spatial reference data so that when you open the file up in whatever program, it displays in the correct location. Since we're exporting to a SHP shapefile, it automatically selects the esri.prj file for us, as well as the Golden software reference files for future use in Surfer. If you know you plan to use a newly exported file in a certain program, I would recommend looking up what reference files that program supports and adjusting your spatial reference preferences accordingly. Then finally, we have the shapefile specific options here. Since we are exporting to a shapefile, I'm going to leave them as the default, but here's where you would change how points, line, and text are rewritten and saved. Then once you're happy with all of your settings, you can click OK to finish the export. Now let's add that shapefile we just made back into Surfer to see if we successfully converted and rewrote the data to unprojected latitude and longitude. To do so, I'll click Home, New Map, Base, and I'll select Diablo Roads latitude and longitude. I'll turn off the original file and drag this over. And right away, I can see that the axes have been rewritten correctly, but the true test is going to be expanding our contents window and looking at a polyline, and our polyline coordinates have also been rewritten to latitude and longitude units. So we successfully performed that export, and that is going to wrap up the basic exporting and overlaying of map layers in Surfer. So I'm going to take a few minutes to address some more questions. All right, one question I'm seeing is, can you do this with multiple different map source layers? The answer is yes. It's the same process. Let me go ahead and turn this other shapefile layer on to demonstrate it. Okay, I'm going to reset this one to UTMs to demonstrate this. Okay. And as long as everything has a source coordinate system set, even if it's different, you can drag it into something that has a target coordinate system. And even if they are two different source coordinate systems, they will both display fine within Surfer. I'll change the color so we can see that they're both in there. So you can have as many different source coordinate systems as you want, so long as it's been properly set beforehand. All right, another question I'm seeing, what other types of files can you export besides a shapefile? There's a long list of different files we can export to. Here, I'll just click File, Export, Save as Type. You've got BLNs, can export to a data file like a CSV, can export to a KML if you were going to go into Google Earth, PDF if you wanted to make sure you got that aerial image, general image files. All of these different export file types will have different export options that you may have to set differently, but our Surfer help does list out what all of the export options mean. If you're ever going through it and you're not sure what something means, just open up the Surfer help and search PDF, for example, and it will tell you what each export option for PDF means. And one more question I'm seeing here is, how do I know if Surfer has the coordinate system that I am looking for? This is just going to be, there's a couple different ways you could search for this. The assigned coordinate system window, it's literally preloaded with like hundreds of different coordinate systems, but you can utilize this search tab if you want. You can search by an EPSG code, which is a 4-number code that is assigned to recognize coordinate systems. And if you search by an EPSG code, let's see if I don't have one written down, but see if that didn't come up with one. But it's essentially an EPSG code is a 4-digit code that you can search by. You can also search by a keyword that's in something. If I would search Lambert, for example, it'll then start refining my answer, and I could expand this until I eventually got to the Lambert that I was looking for. Okay, and one last question is, what is the difference between assigning a coordinate system in the plot window versus new projected coordinate systems, new projected coordinates in the worksheet? New projected coordinates is for those raw coordinates beforehand, and this setting a coordinate system here in the plot window, unless you save and export, it's for displaying the coordinates in that specific coordinate system. All right, and now I am going to move on to our next section here. Once again, if you still have any more questions, Drew can type you an answer, or we will follow up via email after this webinar. Okay, and the last 2 workflows that I'm going to cover here today are a bit more use case specific, but they're going to demonstrate the ways you can modify existing systems to present the data in your preferred format. First, I'm going to cover how to edit a coordinate system to display your data and map in units that are different than the native units of a supported system. For this example, I'm going to change the UTM zone display units for the shapefile that we've been using from the standard meters to kilometers. And to modify an existing coordinate system, you would select the map object that you want to change in the contents window, then go down to the property manager and click change on the target coordinate system. Once you're in the assigned coordinate system window, make sure that you have the right coordinate system that you want to modify selected. And then we're going to utilize this modify button that's here on the right. When you click modify, you open up all of the settings for defining the coordinate system, and you can then alter these as you see fit. For this example, we specifically want to change the linear units here. Right now it's meters. I can use this drop-down menu, and I can change it to any of these already loaded in units that we have here. I'm going to change it to kilometers. And notice once I change it to kilometers, the scale automatically updates. from 1 to 0.001. And I can go ahead and click OK to apply that change. Also notice when you modify a coordinate system, it will now say edited next to it. This is so you know, like if you modify something that's in your favorites, you'll need to re-add the original coordinate system into your favorites or unedit it. If you use this again in the future in its edited form, something will display in kilometers instead of the standard meters. To then fully apply the change, I make sure I have that edited coordinate system selected and click OK. And now we can see my units along these axes have changed from meters to kilometers. And any additions that I make to the map now are actually going to incorporate that change. If I were to select the map tools on the ribbon, I could then go to add to map and add a scale. And my scale is here in kilometers. And this is just a handy, super simple way to demonstrate to a client that, for example, this area they're looking at here covers about 10 kilometers, 12 kilometers along the x-axis. And for our last example today, I'm going to demonstrate how we can edit a unreferenced local system to display our preferred linear units. You might use this workflow if you were given an unreferenced site plan, and instead of wanting to apply a whole coordinate system like WGS84, UTM zone, whatever, you just want to display the linear units like meters along the axes. So for this example, I brought back the demo grid that utilizes those arbitrary numbers along the axes here, and it is in an unreferenced system still. But by setting a source coordinate system, we can tell Surfer that these arbitrary numbers actually represent a linear unit. To do so, select the map layer here in the contents window, come down to source coordinate system and click set. And then we have the option to create a new local system. And that is what we are going to do. We're going to click new local system. And here I can set the linear units that I want this unreferenced local system to utilize. I'd also be able to incorporate any specific X and Y offset in my data here. And I'm going to go ahead and set this to meters. Once you set it to however you like, you can also name it so you could use it again in the future if you wanted. I will call this local meters. I could press OK. And now I have down here in this custom list a local meters coordinate system. I could also add it to my favorites so I could quickly find it again in the future. And then I could press OK on that. And we're going to get an error at first, but that is because we don't have the target coordinate system set yet. I can do that by selecting the map object, coming here to change, and using that local meter system I just created. Click OK. And now if you'll notice down here in the status bar, as I scroll through the map, it does say the meters behind those units. And if I wanted to, I could even modify this to change the units again. I could select the map object, come to the target coordinate system and click change. Then use that modify tab. I could change this to something such as feet. Okay, and now I have that edited denotation next to my local meters, but if I clicked OK, now all of these have been converted to feet. As you can see along the axes, it also denotes FT feet as I scroll through the map down there in the status bar. And that's going to wrap up the examples that we have for today. I hope that by attending this webinar, you're able to see firsthand that no matter what format your data or map layers are in, Surfer can help you assign and convert to the coordinate system you need for your final output in just a few simple steps. One key takeaway I would say for a proper conversion is making sure you're setting those source and target systems correctly. And it's always easier to split out into individual map layers when you need to. It can be massively frustrating if you use the add to map functionality, add an unreferenced data layer, and cause that massive warp again. Later this week, we'll send each of you the recording of this webinar and the data used so you can follow along at your own pace or send it to a friend. And if you are a prospective user and this webinar has you intrigued on trialing or purchasing Surfer, please chat your email or leave it in the Q&A, and our account management team will personally follow up with you later this week. If you are already a longtime Surfer user, I would really recommend ensuring you have active maintenance right now. We have one of our most exciting Surfer releases yet next month, as 3D gridding is going to be added into Surfer. You can also reach out to our sales team to determine if you're eligible to that upgrade next month and how to do so if you're not. And that's going to end my spiel. So now I can address some last questions that are coming in. And if we do run out of time while I'm going through these questions, we will follow up with you via email. One question I'm seeing, are other webinars available if you have active maintenance? Yes, if you go to our website, there's a support tab along the top. If you hover over that, it will say webinars, and then you can look at all of our previous webinar recordings. All of our previous webinar recordings are available on YouTube and our support site. And it looks like Drew just chatted that into the webinar chat for everybody if they would like to take a look at that. Okay, can you explain the difference between WGS84 unprojected and WGS84 UTM projected data? Are both in latitude and longitude? So they aren't both in latitude and longitude. Going back to the start, that's the difference between a geographic and projected coordinate system. A geographic coordinate system is like based on a sphere like the globe, and it's not necessarily meant for showing z values, three-dimensional values, and it's in latitude and longitude. Then UTM projected data is in meters or feet, and it accounts for three-dimensional projection of things that are underneath the surface, things of that nature. And as an expansion on my answer to the unprojected versus projected, the units of a unprojected WGS84 is decimal degrees. Projected UTMs is meters or feet. Okay, and I'm not seeing any new questions come in, so feel free to take off. Thank you everybody for attending. We really appreciate your attendance. And Drew and I will stay around for another couple minutes here in case you have any extra questions. Also, feel free to reach out to our support team or sales team with any questions you have. Thank you again, and I hope everybody has a great rest of their day.